Hello to Ellie and Carter and anybody watching 8th period. This is section 7-3. We are boot scooting right along. This is only going to take one day to do, unlike 7-1, 7-2, but this is graphing. And I know that we don't think graphing is very pleasant, but, you know, it's not too bad. So, graphing reciprocal functions. We actually know what a reciprocal function looks like when you graph it. The parent function for a reciprocal function is 1 over x. Okay, what do we call those guys? They're boomerangy things, right? They look like little boomerangs in the corners, right? Okay, that's what he looks like. Okay, but then keep in mind that when you graph him, he has a dotted line here that those guys will never touch, and he has a dotted line here that those guys will never touch. Do you remember what those are called, those dotted lines? Those are called asymptotes. They are asymptotes, asymptotes. Okay, asymptotes. We'll talk about those asymptotes. Now, this one I call a VA, which stands for vertical asymptote, because it is vertical. The other one, I call it a HA, because it's a horizontal asymptote, because it is horizontal. Makes sense? So when we're doing these and we're graphing these, those are the two main things that you're going to look for when you're doing your VA and your HA. Okay? Happy with that? Okay. So for right now, let's go down here to this first example, and it talks about limiting the domain. What is domain again? X is, like what X can be and what X cannot be, okay? So if I just look at this and we're trying to find where he is not defined, okay? What do I want to make sure does never happen when we have rational functions? I want to make sure this never happens. Yeah, right, that's what it will be, but what we never want 0 to be on the bottom, okay? So this is one where you probably can't do it in your head, or maybe you can, I don't know. But if you can't do it in your head, we say that 2x plus 5, we never want that bottom part to be 0. So we want him to not be equal to 0, right? That bottom part, we don't want him to be 0. And then we just kind of solve for x just like we would if it was an equal sign, okay? So what would you move first? Minus 5, okay? All right, so we want 2x to never be equal to negative 5, and then we would divide by 2 and divide by 2, and x we don't want to be equal to, yep, negative 5 over 2 is negative 2.5, okay? All right, and so what this does is x can't be negative 2.5. Do you know what happens at negative 2.5 on the graph? If x doesn't touch there, like here's negative 2.5, this would be like this guy right here. And we don't have any x's that touch at negative 2.5. You know what happens to it? What happens at that place if he's not touching? What's happening on the graph if he's not touching there anywhere? He has a vertical asymptote, right? He's not touching anywhere at negative 2.5 for the x, right? And all of those x's, he's not touching anywhere. So that's what's happening, and that has shifted my graph over 2.5. Does that make sense? And that's what he looks like. My horizontal asymptote is not moved. We'll talk about what moves him, but it stays at 0. But the other one, x is not negative 2.5, and that's where my vertical asymptote is, right? If x can't be that, that's where the vertical asymptote lives. Clear as mud? Confusing? We'll do some more. It's fine. Okay, let's go down here and let's talk about these guys. So we've got asymptotes. It says identify the asymptotes. We have two different types of asymptotes, and they are called a vertical one and a horizontal one. So they're asking for vertical, horizontal asymptotes. And then they ask for domain and range. Okay, vertical asymptotes, horizontal asymptotes, domain and range. Okay, all right, so if I do some dotted lines here, like where the asymptotes are located, they don't have them written on this graph here. I'm going to do this. I'm going to make this line darker so that we can tell that these are my x and y axis. Can you see that? That's where your y-axis is and your x-axis is, okay? I'm just going to make those darker a little bit. And where will your vertical asymptote be? That dotted line where he doesn't touch. Where is he located? At 3. How did you determine that? By looking at the graph or by looking at the equation? Do you see this equation? Right? Look at his bottom, x minus 3. So what can x not be? Positive 3. right? Does that make sense? By looking at that x minus 3 on the bottom, that tells me where my vertical asymptote is located, right? Vertical asymptote's at the bottom, not equal to 0. So the VA is x equals 3, right? Okay? The horizontal one, the one that goes left and right, where is he located? Still at 0. He's still across here at 0. That's where he's kind of like not touching. So how do we write the horizontal asymptote? Y equals 0. Yeah, right? Because the y, it's cutting through the y-axis, okay? Now, so let's talk about our domain and range. Okay, domain is x's, and x's go left and right forever, right? He's going to the left forever. He's going to the right forever. So is my domain all reals? Kind of. He's all reals except for x equals 3. He's not touching at 3, right? It's all reals except x equals 3, right? He's not touching right here. So he's touching every other place except for that one line, right? Well, one place, okay? Now, the range is the y's that go up and down, okay? He will go up forever, right? This will go up forever, and this one will go down forever. So is he all reals? No. Kind of, except he's not touching at y equals 0. So he's all reals except y equals 0. Okay, now do you see a correlation here, folks? Oh. Do you see a correlation here, folks? Your VA is x equals 3. That means x doesn't touch 3. That's where your domain is. Your HA is at y equals 0. That means your range doesn't touch y equals 0. That's the way that it is every single time, right? Okay, good. Okay, all right. Here we go. Let's go over to this next one. All right. I'm going to write out my x and y axis. So here is the, oh, that was really bad. Here's the x axis if you want to make him darker. Do you see your y axis? Right here. That's the y one. Okay. So I just kind of make them a little darker so that we can see where they're located at. Where is the horizontal or the vertical one at? Where is he moved? At -2. Do you see where he's at? Okay. Now, if you were looking at the equation, can you tell that that's -2? How do you know? X plus 2 is the bottom. So x can't be -2, right? Or yeah, x can't be -2. So for my VA, x equals -2 is my VA, yeah? Okay. The horizontal one is not at 0 anymore. Where's the horizontal one located? At -1. Okay, what in the equation tells you he's at -1? This guy, because this number is moving him down 1. That's what that number does. So the fact that I didn't have a number on the end of this equation over here doing plus and minus means that the first one wasn't moved up and down at all, but this one is over here. He's moved down. So what do you put for AHA? Y equals -1. Okay, then for domain and range, okay? Domain is all reals except for x equals -2. Now, here's what you can do. Rather than putting all reals except x equals -2, you can just say x is not equal to -2 if you would like to do that instead, right? And that just tells me everything else but -2, right? So you can either put this or this, and that is perfectly fine, okay? So for range, what will you put your range as? Range is up and down. He will touch everything up and down except for? Except y equals -1. Or we could just say y can't be -1. Okay? Make sense? Good? All right. Let's go down to this box right here. And I'm going to not talk about this box with all of the terminology that they have. I'm going to talk about it over here. So go to the front side and go right here. And let me talk about some things right here. Let's say you have this. Let's say you have -3 over x plus 4 minus 2. I'm going to tell you what all of those numbers mean. Okay? All of those numbers mean. So write that example in there. negative 3, x plus 4 minus 2. I'm going to show you what these mean. Okay? We already know what the negative 2 means. How does that move him?
Down 2.
It moves him down 2, right? That makes him move up or down. If it was a plus 2, it would be up 2, right? Okay? Now, when he's moved down 2, does that affect the ha or the ba? The ha, that's where my ha is located, okay? So I'm going to put ha in parentheses there because that's what tells you where your ha is located. Does that make sense? Okay, let's circle this guy right here, x plus 4. How does that thing moved? Left 4. Okay, plus means left, minus means right. He is moved to the left 4 because if you set x plus 4 equal to 0, x equals negative 4, right? Okay, that's what he is at. So left 4. Does that affect my ha or my va? Your va, right? Okay. All right, I'm going to do a little rough sketch of what he will look like over here. Here's my graph, okay? And here's what I'm going to do. If I'm having to graph him, I'm going to go to the left 4. 1, 2, 3, 4 to the left and down 2, and I'm going to put a dot there. Okay? Ready? Left 4 down 2. This is how I graph him. That dot is where these two guys are going to come together. Do you see that? My vertical and horizontal asymptote. That's what he looks like. Make sense? So when you're graphing it, it's pretty easy. You just find those two places and put a dot and cross them there. Okay? Now, before you graph him, don't graph him. Don't graph him yet. Don't graph him yet. Because we have a 3 and we have a negative. Okay? Let's talk about the negative first. How does that thing affect him? What's a negative do usually? It reflects him, okay? So when he is reflected, instead of being in these two quadrants, right? It's going to make him be here and here instead. So anytime there's a negative, you're going to put him like in the second quadrant and the fourth quadrant instead, okay? Now, what does the 3 do? Most of the time that number is a 1. If it's a 3 instead, it's like you're multiplying it by 3. What happens when you multiply like u by 3? You stretch him out. You make him taller, okay? So when we make him taller, let me show you what it looks like. He's going to be taller, and he's going to be like more of a C and less of an L, right? Rather than being like this, he's going to be more of a C and less of an L. If we stretch him out and make him taller, right? We're like stretching him up. Okay, so he's going to look more like a C and less of an L, and we're going to be in this quadrant and this quadrant. Okay, I am not really particular about the numbers, just kind of visibly make him more of a C and less of an L. Make sense? Ish? Okay, so that's kind of like the shortcut to graphing these. Good? Okay, let's go to the back side. Did you get all that written down? Maybe? Go to the back side. Let's go here. And I'm going to change part A because I don't want to deal with 1/2. Blah, 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 blah. I want to deal with 1/2. So cross him off. We're just going to pretend that he says x minus 2. Right? X minus 2. So let's figure out some things here. This plus 2 is going to move him how? Up 2. This 2 right here moves him to the right 2 because minus means right. So right 2. So I'm going to go right 2, up 2, and I'm going to put a dot. And then what? That's the dot where my vertical one and my horizontal one come together. Okay? All right. Do I need to stretch him out?
No.
No, because it's just a 1. Do I need to reflect him?
No.
No. So he literally just looks like this. That one and that one. Ugh. Do your best. Mine is really ugly. Sorry, guys. And then they say state the domain and the range. Okay, they don't actually have us do the va and the ha, but we have them graphed there, right? Domain and the range. Okay, domain is the x's, left and right. He will touch everything except for the x's will not touch 2. So we can say x is not equal to 2. Or if you want to say all reals except 2, that's fine. Either way you want to put it, whichever one makes the most sense to you. The range is going to be all y's except for also 2, right? The y coordinate 2 is where he does not touch. He's going up forever and he's going down forever. But there's like a little blip here where he doesn't touch at all, right? Is this confusing? No? Not too bad? Okay, B. Hey, I almost gave you this exact same problem on the front side. What the heck? All right, here we go. Let's do the -4. How does that move him? Down 4. Okay, the +1, how does that move him? Left 1, right? Okay, so let's go left 1, down 4, left 1, down 4. There's my dot, and I'm going to do my vertical and horizontal asymptotes just like that. Okay, do I need to stretch him out? Yeah, just a little bit because there's a 3 there. And what else? Reflect. I'm going to put a star. R-E-F-L-E-C-T. So he needs to go in the kind of like the second quadrant and the fourth quadrant, right? So like here, and we're going to make him stretched out a little bit. There. And here. Something of that nature, right? Okay, so more of a C and less of an L. There's a 3 there. I don't get particular about where your points are plotted. I am A-okay with that. Okay? And we need to do a domain and range yet. Am I going too fast? Are we doing all right? We're like almost done. Holy cow. This is going to be easy. Okay? Domain. Domain is going to go left and right forever, right? He goes left to forever, right forever, all those good things, right? Except he doesn't touch this spot here in the middle, which is at? There's no x at -1, right? There's no x there at -1. The range, he goes up forever, he goes down forever, but he doesn't touch this guy here in the middle, which is the y's are not equal to -4. Okay? All right? What do we think? Is this okay?
No.
Would you rather do 7-1, 7-2 stuff, or is this easier or harder? Which one? It's easier? Yeah, it's easy. It's unpleasant because we never like to graph, right? But, you know, if we have to, this is not too bad, right? Okay, we're going to do example 4, yep, because I like this one. Philip is taking a non-stop flight to Hyderabad, India, okay? For a business trip, and a one-way trip is about 9,000 miles, okay? Write an equation to represent the travel time to Hyderabad as a function of flight speed. Then graph the equation. They went ahead and gave us the equation for us. So they did part A for you. The time that it takes depends on how fast I'm going, right? I take and divide by the rate.
Do you have sophomores and juniors?
When do I have
What
sophomores?
periods?
Juniors I have mostly 4th period, and sophomores I have mostly 1st and 5th.
We're gonna do job fair test prep during the school day this year.
Oh,
again,
nice. Okay.
But we're just gonna rotate the periods.
Oh, cool.
So like next week we'll start like first period.
You're going to have all sophomores and juniors take it?
It's just all juniors for sure, and any sophomores that wanna take it.
That want to take it. Okay, cool.
I don't want all sophomores that don't wanna be there.
Right. That makes sense.
So then on the days we do that, you might miss third period kids. So that day.
You know what? I'm okay if you want to take my 4th period class all the time. That's fine.
Yeah.
So anyway, okay. Actually, they'll probably have to do it in here, and I'll have to do it. But whatever, it's fine. All right, so they gave you an equation for that, right? Does that make sense that the time that's required depends on the rate that you travel, right? Do you know how fast an airplane usually goes?
Really fast.
Really fast. Like how fast?
500.
What?
500.
500 miles per hour? Some of them, it usually anywhere between like 300 and 500 miles an hour, right? Like I think most of the time, like most planes that I was on was like 375 or something like that. Okay, so let's just round down. Let's say that you're going 300 miles an hour, right? Let's say our rate is 300. How long is it going to take you to get there? Assuming that air resistance and you're not like going against the wind or anything like that. Okay, assuming that is not a thing, how many hours does it take you to get there? What? 30 hours, right? 9,000 divided by 300, 90 divided by 3 is 30 hours. That's a long time because that's a long way to go, right? India's like all the way across the whatever, right? They're probably going to go faster than 300 miles per hour to kind of make it like go faster. But anyway, so 900 divided by the rate is going to give you the time. Okay, so that's kind of how that works. Now they have graphed this thing, okay? But I don't know that I really like their graph, right? This axis is representing time, and this axis is representing rate, okay? What's wrong with their graph?
They don't have negative.
You can't go negative, right? So this little bottom half of my boomerang function shouldn't even be there, right? He should not even be there. So they only should have graphed this guy, which is fine. And he kind of looks like an exponential function, doesn't he? Yeah, so he's kind of similar to an exponential function if we just look at the top boomerang. But really, if we were being realistic about this, there's no need for us to graph any of the other quadrants, right? Just the first quadrant would be fine, okay? Explain any, oh, there we go. Explain any limitations to the range or the domain in this situation, okay? As far as domain goes and range goes, which variable is the domain again? Is it rate or time? Which one's domain? Rate. How do you know that? Domain is usually x, and the x-axis is labeled as rate. So the rate has to be what? Greater than? Can it be equal to 0?
No.
Could you be going a rate of 0 miles per hour? I mean, you could. You're not going anywhere though. So we could have a rate of 0. You wouldn't be going anywhere, but you could have that, right? Like it could be, it could be a thing. It's like before you take off, you're going a rate of 0. Range is the y coordinates, and the y is represented as time. So time is going to be what? Also greater than.
Not equal to.
Can it be equal to 0?
Because you'd have to be going under 5 miles per hour.
Actually, you know what? The way that they've written it as the equation here, we can't have it equal to 0, right? Because what if it was equal to 0? We would be plugging 0 into the bottom, right? So I think for this particular example, we're not going to be discussing anything where it's equal to 0. So let's go ahead and just say greater than. Time will strictly be just greater than 0 also then. Does that make sense? Yeah, so even though you could technically have a rate of 0, you're not going anywhere. If we're going to use the equation, we wouldn't be able to because you can't divide by 0. Okay, happy with that? Okay, not too bad. Let's talk homework. Did I give you the homework? Yeah? Okay, let's do on skills practice. There's only 6 problems. Let's do all there. And then I'll cut the back side down a little bit. All on skills practice, and you say evens. But I like 7. But I like 7. You're killing me.
Okay, what if the rest of us have?
What?
What if Carter and Ellie have questions?
What do you mean?
We could do evens and 7.
No. That's even worse. No.
So he's trying to give me more reason to give him evens. Whatever, we'll do evens. I don't care because it's Friday and I'm trying to make it a good day. So all in evens. How about that? Okay. All right. Bye, Carter and Ellie, and whoever's watching 8th period.